Today, the student will be able to use the properties of multiplying and dividing fractions in order to simplify expressions. So we are still simplifying rational expressions, but before we do the simplification, we're going to multiply or divide. Really, what you need to understand is that to multiply rational expressions, you're going to multiply the numerators and multiply the denominators. Same thing we've been doing with fractions in general. If you have a fraction a over b times a fraction c over d, you do a times c and b times d. Then from there, we can use what we learned yesterday and the day before to simplify. Now, you're still assuming that your denominators are not equal to 0. So you still have to check and see when you talk about the domain, you still have to check and see if b or d, what would make them 0, because those can't be answers, okay? When we divide, you can't really divide fractions. So in order to divide a rational expression, you're going to multiply. So division always turns to multiplication, but you're going to multiply by the reciprocal. So if you were looking at a over b divided by c over d, the c over d reciprocates and becomes d on top of c, and your division turns to multiplication. So remember, you're going to keep the first, change the sign to multiply, and reciprocate the other, okay? Now, that kind of brings up some weird things when we're talking about our domain. You know that the denominators can't be equal to 0, but we are reciprocating this fraction. So yes, d can equal 0, but neither can c. So when you check for your domain, you're going to check the original denominators and numerator of the second fraction. That's really all that's new today. All right, so let's go ahead and get started. So on this first example, we're going to multiply these two rational expressions. Now, in each fraction, there's no plus or minus sign, so it's pretty easy. Everything's multiplication. The first thing you'll notice is that it's multiplication, so we're going to check the denominators. Basically, this means that y can't equal 0 and x can't equal 0. And I could do that pretty fast because it's all being multiplied. The only number for y that would make that denominator 0 is 0. If it were any other number, it would multiply to 21 and be cubed and be not 0. So if you only have multiplication, no plus or minus or anything else happening, then you can just say that your number can't be 0. All right, so we're going to multiply across. So 8 times 7 is 56. We have an x and we have a y squared. 21 times 16 is 336. We have a y cubed and we have an x cubed. Okay, the first thing I'm going to look at is, and you can do this in lots of different orders, but I have an x on top and an x on bottom. Remember when you have, again, there's no plus or minus. So all we're using to simplify here is our exponent rules that we learned a long time ago. So we don't have to factor anything because there's no plus or minus signs. If I have an x on top and x3 on bottom, we learned before that in order to simplify that, you subtract the exponents. So when division is shown, you subtract the exponents and keep it where the larger one started. So somewhere on the bottom, I'm going to have an x squared because the 1 and the 3 give you a 2. The y's, so I'm looking at y squared and y cubed. My y is going to be on the bottom because the 3 is bigger than the 2. And when I subtract those, I end up with 1. The 1 doesn't have to be written. All right, now I can look at my coefficients. 56 over 336. That's just a fraction. 56 divided by 336. So you're going to simplify that fraction just like you've always simplified fractions. 56 goes into 336 6 times. So I have nothing left on top, so we're going to keep it a 1 because really it's 1 over 6 is what that simplifies to. And that's it. That's all I got. So the simplified answer is 1 over 6x squared y, and we know that y and x both cannot be equal to 0. All right, on number 2, I'm dividing. So I'm going to keep the original fraction the same. So 10m k squared divided by 3c squared d. Change the divide to times and reciprocate the fraction. So 6c squared d squared over 5m squared. Now, when we talk about what our domain cannot be equal to, I have to look at this and this, and because it's division, I have to look up here also. Again, there's no plus or minus, so the only number we're looking at that we cannot have is 0. So that means that C cannot equal 0, D cannot equal 0, and M cannot equal 0. Oops. We have one more letter here. We have a K, but we don't care what K is because it will never be on the denominator of the fraction, so it's not going to affect the domain. All right, so now let's multiply what we got. So 10 times 6 is 60. M is still M. K squared is still K squared. And then I also have a C squared and a D squared. The order does not matter. Because there's no plus or minus signs and everything is being multiplied, there's an algebraic property called, I just lost it. It's a commutative property in algebra that says that the order you write your things don't matter. Okay, 5 times 3 is 15. I have a C squared, a D, and an M squared. Okay, so let's start simplifying some of our things. If I simplify the numbers 60 over 15, well, that's going to simplify to 4. Technically 4 over 1, but I don't have to write the 1 on the bottom. All right, now let's look at, I have an M and an M squared. Technically, this is an M1. I'm going to put my M on the bottom because that's where I started with the most. And 1 and 2 subtracted is going to leave me with 1. Okay? Then let's look at okay, sorry, I was looking at something wrong. Okay, then we're going to look at, I have C squared and C squared. Well, if I subtract those, I get an exponent of 0, which really just means I have 1 whole. So the C's are completely gone. They have simplified themselves. All right, last, if I look at, I have 1 D on the bottom and 2 on top. So I'm going to be left with the D on top, and the exponent is 1 because 2 minus 1 is 1. So I have, let's not forget this, K squared wasn't affected by anything because there's no other case. K squared. So I have 4DK squared all over M. And I know that C, D, and M cannot be 0. All right. Next, same kind of situation, but we're just multiplying. So 3 times 5 is 15. I have an X and a Y squared. 15 times 2 is 30. I have an X cubed. All right, so if we simplify this, 15 over 30 simplifies to 1 over 2. I have 1x on top and 3 on the bottom. So my x's are going to stay on the bottom. And if I subtract the 1 and the 3, I have 2. Oops. Okay, then I have a y squared that's not going to be touched by anything. So the only other thing we can do with this is we can write it as just y squared over 2x squared. Okay, now we didn't talk about what our domain is. To check the domain, I'm going to check this and this. Now, 15 doesn't have a variable, so that doesn't tell us anything. But we know that from the second, x cannot be equal to 0. All right, next. We're dividing again, so we are going to rearrange this. We're going to keep it 3x squared y over 20ab, but then we're going to change to multiply, and we're going to reciprocate the fraction, so 5a squared b cubed all over 6xy. Now let's talk about what is not allowed to equal 0. So I'm looking at 20ab, 5a squared b, and 6xy. Now, again, there's no plus or minus, so the only number that would affect us is 0, so we know that a can't be equal to 0 because then the denominator would be 0. B can't be equal to 0 because the denominator would be 0. But then because we're dividing this numerator, that's also going to put x and y in our conversation of numbers that we cannot have. So we're going to simplify this, assuming that a, b, x, and y do not equal 0. All right. Now let's just multiply what we got. So we got 3 times 5 is 15. 20 times 6 is 120. All right, x squared, y, a squared, b cubed. And then I have a, b, x, y. Okay, the first thing we're going to do is simplify 15 and 120. So 15 goes into 120. I think it's 8 times. Yeah. So 15, oops. So if I simplify this, I get 1/8. Okay, now let's talk about, we've got x squared and just x, so that's going to leave us a single x. We've got y and y. Well, those are exactly the same, so they're going to cancel themselves out. We've got a and a squared, so that's going to leave us an a on the top. And we've got b cubed and b, so we're going to have a b squared on top. So I don't need to write the 1. I have an x a b squared all over 8. All right, next. Okay, now so we're getting into polynomials that are bigger than just, all of these are just monomials, one term. So we did 1 term times 1 term. But now we've got binomials, so 2 terms, and trinomials, 3 terms. So things are going to get a little different, but it's really not bad. So really what we have is, when we multiply this, we have a k minus 3 times a 1 minus k squared. But that is not how we normally write that. So I'm going to write it as negative k squared plus 1. Okay, divided by k plus 1 and k squared minus 4k plus 3. Okay, now that I have it set up, now I'm going to factor anything that can be factored. K minus 3 cannot be factored, so it's going to stay. This term can be factored, and if the a, the very first number, is a negative, we're going to take a negative 1 out first, and then that means we've got k squared minus 1. That's going to factor into k minus 1 and k plus 1. Okay? Then on the bottom, k plus 1 won't factor, but k squared minus 4k plus 3 is going to factor, and that will factor into k minus 3 times k minus 1. Okay, so now we can cancel out our like terms. So we have a k plus 1 on top and bottom, a k minus 1 on top and bottom, and a k minus 3 on top and bottom. So the only thing I'm left here is negative 1. Okay, now we still have to talk about our domain, because we still need to assume that k is not numbers that would make the denominator 0. Otherwise, these fractions wouldn't matter. So from the first one, k plus 1, I know that means k cannot equal negative 1. And then from the bottom, this k squared minus 4k plus 3, that factored into k minus 3 and k minus 1. So I know that k cannot equal 3 and k cannot equal 1. Okay? All right, next. We've got, if we set this up first, we have 2d plus 6 over, d squared plus d minus 2. Now, when I write the other terms, I need to reciprocate the fraction. So the d squared plus 3d plus 2 is on top, and the d plus 3 is on the bottom. Okay, now I can factor quite a few things. So first we can factor 2d plus 6. There's not a d squared in that, but they do have a like term. 2 can be taken out of both. So really I have 2d plus 3. Okay, then I can factor oh, let's not use yellow because I'm using yellow for the other. D squared plus 3D plus 2 will factor into D plus 2 and D plus 1. Okay? Next, if I take D squared plus D minus 2, that factors into D plus 2 and D minus 1. And then D plus 3 doesn't factor. So let's rewrite what we have there. So we have a 2, D plus 3, D plus 2, D plus 1. On the bottom, we have D plus 2, D minus 1, and D plus 3. Okay, now, D plus 2 cancels, D plus 3 cancels, D plus 1 and D minus 1. So I have 2 D plus 1 over D minus 1. Okay, now let's talk about what the domain cannot be equal to. So I need to look at this and this, and because it was division, this one also. So the top one's easy. D plus 3 can't equal 0, so D can equal negative 3. Okay, now D squared plus D minus 2 factored to this, so that tells me that D also cannot equal negative 2 or positive 1. And then if I look at this one up here, that means D cannot equal negative 2, I already have that, and D cannot equal negative 1. That's a lot of numbers that D is restricted to. Okay, next, we have x minus 3 times x squared plus 5x plus 6. So I have x minus 3 times x squared plus 5x plus 6 divided by x plus 2, x squared minus 9. Okay, we can factor x squared plus 5x plus 6. That factors into x plus 6 and x plus... No, that's wrong. X plus 2 and x plus 3, sorry. X plus 2 and x plus 3. We can also factor x squared minus 9 into x plus 3 and x minus 3. So really what I have is x minus 3, x plus 2, x plus 3, all divided by x plus 2, x plus 3, x minus 3. Okay, so I can cancel x minus 3, x plus 3, and x plus 2. If everything cancels, then that means that my fraction simplifies to one whole. Just like if you had like 5 over 5, those cancel each other, so there's nothing left. They simplify to one whole. So if everything is gone, you just have one. All right. Now let's talk about what x cannot equal. So that all works as long as my domain restricts certain x values. So from x plus 2, I know that x cannot equal negative 2. From x squared minus 9, I know that x cannot equal negative 3, and x cannot equal positive 3. From x squared plus 5x plus 6, I know that x cannot equal negative 2, but that's already there, and x cannot equal negative 3, but that's already there. So we have covered all of our bases. All right, last example. I have 3d plus 9, but this is going to multiply to the denominator of the other. So d squared plus 5d plus 4 divided by d squared plus 4d plus 3 times d squared plus 5d. Oh, sorry. Nope, that one on top. So d plus 2. Okay, now we can factor 3d plus 9 because we can take a 3 out. So that can factor to 3 times d plus 3. D squared plus 5d plus 4, that can factor into d plus 4 and d plus 1. d squared plus 4d plus 3, that factors into d plus 1 and d plus 3, and d plus 2 does not factor. All right, so now what we have left is, oh, let's rewrite it first, sorry. So I've got a 3, d plus 3, d plus 4, d plus 1, all divided by d plus 1, d plus 3, d plus 2. All right, so d plus 1 cancels, d plus 3. So I have left 3 d plus 4 over d plus 2. Now, you could written it as, if you wanted to distribute the 3 and say you have 3d plus 12 divided by d plus 2, that's fine. Remember, when we simplify, we're just trying to take out what can be taken out. We're not so worried about what the final answer looks like, okay? But we still need to talk about what our domain cannot be. What is it restricted to? So that cannot be 0, that cannot be 0, and that cannot be 0. So from the d plus 2, I know that d cannot equal negative 2. From the d squared plus 4d plus 3, I know that d cannot equal negative 1, and d cannot equal negative 3. All right. From the d squared plus 5d plus 4, I know that d cannot equal negative 4, and d cannot equal negative 1, but that's already there. And that's all we got.